Well, hello. This is going to be our final ScotTube video about equations. I might do more videos throughout the year, but we're getting ready to dive into Chapter 3. But before we can dive into Chapter 3, we want to take a look at one-step equations. So our two vocabulary words today are equation and inverse operation. These are probably words that you're pretty familiar with, but let's go ahead and define them. For equation, you should write a statement that two expressions are equal. Okay? A statement that two expressions are equal. If we have an equation, this means that we're able to solve. We can find the value for our variable. Okay? In order to solve equations, we'll use this idea of inverse operations. Inverse operations are two operations that undo each other. Things that would be inverse operations, like addition and subtraction. If I add 7 and then subtract 7, adding and subtracting undo each other. Or multiplication and division. Those are inverse operations. We will need both of these words for today's lessons. I would imagine somewhere along the lines, either a parent or a teacher or another adult has mentioned living by the golden rule. The golden rule says, do unto others as you would have them do unto you. In the same way, when we solve equations, we're going to follow the golden rule of algebra. And the golden rule of algebra is, whatever I do to one side of the equation, I must do the exact same thing to the other side of the equation. As long as we follow this golden rule of algebra, we will be awesome at solving equations. Okay? The other thing you have to remember when solving equations is, what's the goal of an equation? My goal on an equation is I want to isolate the variable. Isolate means let's get the variable all by itself. Okay? If you remember these two things, you can be a pro at solving equations. One thing I do want to mention is it's important to learn how to show the work when we're solving one-step equations and two-step equations. I know some of you will think, but Mrs. Davis, I can solve these mentally. Yeah, you can. Do you know what? So can I. But I have taken a lot of math classes, and I know the math that's coming up. And if you don't learn the procedures to solve equations now, when we get to more difficult equations, some that don't even have numbers in them, it's going to be really tough for you to solve them if you don't know how to show the work. Okay, so please, on the notes today, show the work correctly. So let's go ahead and take a look at some of the examples there. We're going to start with example C. Okay, if I look at example C, my goal in example C is to isolate the variable. Okay, so right there I'm looking at the m. Sometimes people will even circle the thing that they want to get by itself. So I want to get the m all by itself. Well, I can see right now the m is living with minus 2. Okay, how do I get rid of minus 2? What's the inverse operation for minus 2? It's add 2. So I'm going to put add 2 on this side. Remembering my golden rule, whatever I do this side, I must do on the other side of the equals. Okay, and then I can see what happens. I have negative 4 plus 2 on this side. That's negative 2. Over here I have negative 2 plus 2. Well, negative 2 plus 2 is 0, so I can cross that out, and I get m. My answer, my solution, m equals negative 2. If that bothers you to have the variable on the right side, you can flip this around and write m equals negative 2. I'm fine with this as our solution. Let's look at example E. In example E, I would like to isolate the x, get the x all by itself. Right now I can see the x is living with times negative 8. And I know it's times negative 8 because there's nothing in between there. Okay? So, if I want to get rid of times negative 8, I'm looking at what's the inverse operation for multiply negative 8. It's divide negative 8. Okay, so I'm going to put divide negative 8 on this side. Also put divide negative 8 on that side of the equals. Okay, one important thing to note here. The reason that this cancels is because negative 8 divided by negative 8 gives me 1x, which is what I'm trying to get. Okay, so that will cancel out and leave me just with x. On the other side, negative 64 divided by negative 8 is 8. My solution, x equals negative 8. Let's also take a look at G. If I'm looking at G, I would like to get the Z all by itself. I can see right now that the Z is living with times 2/5. So I need to get rid of times 2/5. Well, to get rid of multiply 2/5, I would divide 2/5. However, you might remember that when you divide by a fraction, we're going to multiply by the reciprocal. So dividing by 2/5 is really the same as multiplying by 5/2. So to get rid of this, I'm going to multiply both sides by 5/2. See what happens here is I get 10/10. Well, 10/10 is 1z. That's what I want to multiply by. Over here, I might put a 1 underneath here. I have little simplifying the diagonals. I end up with 5 times -2, which is -10. My final example, I'm going to pick out L. L looks like this. We've got a negative out in front of r/3. When I look at this, I have a choice to consider that negative on the top, that negative on the bottom. Okay, so one choice here might be, okay, I want r by itself. I could view this negative as going with the 3. Okay? Then if I want to get rid of that, well, to get rid of divide -3, the inverse of divide -3 would be to multiply by -3. When we show our multiplication, we're going to want to show it in the numerator so that we can see that it's canceling out. So if I look at this right here, I have -3 over -3. Well, -3 over -3 is 1. So I just get r on the right side. That will cancel out. And then over here, -3 times -101 becomes a positive 303. One final comment. Number 2 talks about properties of equality. We have addition, subtraction, multiplication, and division. Those properties just say if I add the same thing to the left and to the right of the equation, they're still balanced. They still match, okay? Which goes along with our golden rule. Same thing for multiply. If I multiply both sides of the equation by the same thing, okay, this statement still holds true. Those are those properties that we're using every time we solve an equation. Okay? Please complete the rest of the examples showing work. I'm going to be looking to see if you showed work, and I look forward to seeing you in class tomorrow. Have an excellent night.